Hello dear students, how are you all? I hope you all are fine and your studies are going on well, I hope. Few students of mine had requested me to upload the video on how to derive the mirror formula in simplest way, that is different way of explanation they have asked. Okay. So in this video we are going to derive that step by step along with the correct order of reasoning we are going to take without skipping the video. If you watch, you will have complete understanding. Okay. Now coming to the mirror formula, before drawing means before deriving mirror formula, we need to understand how do we get the focal length of a mirror. That is also important because most of the times just we say focal length is nothing but r by 2. That is half of the radius of curvature we say. But how it comes, understanding that in depth is very much important because this will help you in your competitive exams, whatever you may attend there later. Okay, whichever the exam it may be. So let us go ahead with first one. This focal length, how we are deriving, then we will come to mirror formula. Afterwards, we'll continue with magnification, right? Now let us take first one here. How to start with? Here some of the definitions in order to save the time I have already written on the board, right? I'm not going to take much of your time. So that is why I've written that. Remaining, I'll be repeating the same while explaining, and remaining I'll be deriving. Next you see. How to start with. Okay, what I've written, same. Here you have to show here the what concave mirror. First one side rough surface you are going to show, right? Now you have to say here let P be the pole of the mirror, okay, and C be the center of curvature of the mirror, okay. Here we are showing this as C be the center of curvature of the mirror. Now the line passing through C and P will be what? This imaginary line, principal axis or not? This is principal axis, okay. Now what you have to say is next, let a ray of light, okay, now let a ray of light incident on mirror at M, okay, let the ray of light parallel to the principal axis strike the mirror at M, okay, at M. Now the line CM will be perpendicular, okay, CM will be what? Perpendicular to the surface of this one, reflecting surface of the mirror. We'll make this one, right? Now CM is, this is not a reflected ray, it is just normal, right? Now after, now with this normal or this perpendicular, it is making an angle, that is angle of incidence I, we can say, right? So angle of incidence is equal to angle of reflection or not? This is law of reflection, you know that already. So the same angle has to be made after reflection by that incident ray. Okay, what we can do is here this ray after reflection it is making same angle and it is reflected back, right? When it is reflected here, here this angle both are equal, right? This is angle R, this is angle I. Now if angle I is theta, then angle R will also be theta or not? Okay, so what we can say is this I we shall replace it by what? Theta. Then angle R will also be equal to theta, right? You have to show the direction of incident and reflected rays of light like this, right? This is reflected ray. Now what we can say is here theta, here also theta. Now let MD, let MD be what? It is perpendicular on the principal axis, okay, principal axis. Now in case if we have any confusion here, CM, how it becomes perpendicular? It is nothing but radius of curvature or not? If you take any circle, if you take the radius, okay, and here if you draw any tangent, to the tangent is perpendicular, you already studied, right? In the same way here also if you take, this is what reflecting surface, just draw on tangent here, to this it is normal or not now, okay. So with the normal, what angle is made by this incident ray? That is angle of incidence, that is theta. This is angle of reflection, that is also theta. Both are equal, right? Now what we can say is here this is M, this is D. MD is the perpendicular on the principal axis, right? Now let us consider here this angle and this angle we have to find out. Very much simple it is. These lines are parallel because this ray of light we are considering, it is parallel to the principal axis, right? Then this and this both are parallel means this is transversal. These are what? Interior alternate angles. Then theta and theta both are equal, right? Now here you can see, consider this point, let us name this point as here this ray after reflection where it is intersecting the principal axis be f. F means what? Principal focus, right? It is principal focus. Now coming to this angle, if you consider, this is the exterior angle of CMF, right? Triangle CMF. Its exterior angle is this one. What is that? MFD is what? Exterior angle. Otherwise MFP also you can say. So this exterior angle will be equal to what? This is equal to 2 theta. Why it is 2 theta? Because you know that exterior angle property, sum of opposite interior angles will be equal to exterior angle of the given triangle, right? So that is why theta plus theta is 2 theta. That is why this angle will be equal to 2 theta, right? You got now. So what we can say is here, let us come to know this one. First here, theta we got, 2 theta we got, right? You consider these angles now. What are those angles? Angle MCP you consider, okay? Angle MCP, okay? What is that? Theta. It is angle theta. Next, angle MFP you consider. Angle MFP will be equal to what? 2 theta, right? We know this from the figure. Now what we can say is here if you consider tan theta, okay, for MCP, tan theta, how can we write this one? MCP, okay. So what we can say is, if you, because here right angle triangle we are reading, if you consider MD, right? So for this we can consider this MCP you take, but here we are considering only this side, okay, because see, this P and D they coincide with each other. Later I am going to explain that one, okay. Now what we can say is here tan theta is equal to what we can say opposite by adjacent. Opposite is MD upon CD we can write, right? MD upon CD we can write, right? Next is tan 2 theta. Tan 2 theta if you consider, this will be equal to what? Tan 2 theta, here 2 theta. This is MD upon FD, right? MD upon FD we can say, right? Now let us call this as equation 1 we'll say for this, okay. Now what we can say is here for small angle, small theta, okay, for small theta, what happens? If you consider this angle very much small, then this tan theta reduces to theta, okay, and tan 2 theta, this will also reduces to 2 theta. How is this possible? Just you consider here, if you take this as tan theta, okay, opposite by adjacent we are taking. What happens? Small angle means what? This has to be straight line. When it becomes straight line, the what here angle of incidence, what it is there with a normal, it has to be very minimum. Then only this becomes very much less, right? This line has to be very much close to the principal axis. Means almost they are just beside each other. Like this, it has to come, right? Then what happens? This side, what we are getting this side, this height, this will be almost equal to 0. It reduces to 0. Okay, it is close to 0 we can say. So because of that, what happens here? Here tan theta becomes theta, tan 2 theta becomes 2 theta we are seeing, right? So how this becomes? Just I'll show you it here. Tan theta, tan 0 you take this one. This will be equal to what? Sin 0 upon cos 0. Okay. Here tan 0 is equal to sin 0 means what? It is 0. Cos 0 means 1. 1 upon 0 is what? 0. So what we are getting here? Tan 0 is equal to 0. We are getting what? So this we can express it as tan theta is equal to theta, right? In the same way, tan 2 theta will also be equal to 2 theta. So that is why what we can say is here, coming to this back here from equation 1, here this and this, if you compare, okay, what we can do is here after changes, here tan 2 theta is there, right? Tan 2 theta is equal to 2 theta we are comparing, right? How to compare this? Tan 2 theta means what here? MD upon FD, MD upon FD. will write. Okay, is equal to 2 theta. Theta is what here? MD upon CD or not? So what I can do is 2 into, okay, MD upon CD will write, right? MD upon CD. Now what this becomes? MD gets cancelled or not? Okay, you bring it to the other side, and these you interchange the terms. What we get here after interchanging? FD comes to the numerator, so FD will be equal to this comes to the numerators, that is CD, and this goes to the denominator, that is divided by 2. CD by 2 you got. Okay, CD by 2 we got. Now for small angle, okay, for small angle theta, what happens when this angle is very much small? This comes down, this line. When it comes down, this D moves away from this point, right? D moves backward, so it coincides with P. Means what? D tends to P when theta is very much small. So what we can say here, for small angle theta, D tends to what? P. D tends to P, we can say. It is almost becoming close to P. So what we can say, instead of FD, can you take this as FP now? This can be CD can be taken as CP by 2, right? Now FP means what? FP is nothing but it is the focal length, right? That is focal length. What we can say is this implies FP is what? Focal length. Let us write it as F, and CP is what? The distance between center of curvature and pole of the mirror. That is called what? Radius of curvature, right? So that is why that is R divided by 2. So this is how we can get. So that is why what we can say, F is equal to R by 2. Okay, this is the relation how focal length and radius of curvature are related. Okay, 2 times of focal length is equal to radius of curvature, or focal length of the mirror is equal to half of the radius of curvature. Once if you know this one, then we can go ahead with mirror formula. Okay, how to derive mirror formula. Okay, let us continue with the mirror formula now. Okay, now let us go ahead with what how to derive the mirror formula. Okay, now how to start with? First you need to consider a concave mirror, right? So if you draw the concave mirror, you have to show it like this. Let Mn be the concave mirror. Okay, Mn. Let us take this one as concave mirror. Let P be the pole of the mirror, right? P be the pole of the mirror, and C be the center of curvature of the mirror. Okay, here C. This is C. If you draw a line passing through the center of curvature to the pole of the mirror, what is that? Principal axis. We'll shift it here. Okay, that is principal axis, right? Now you have to show this is what rough side of the mirror. This is polished side is this side. So now what we can say is here, let AB be the object on the principal axis, right? Let AB be the object on the principal axis. Let us take here, right? This is object on the principal axis. We will show it here. See. Now consider a ray of light which is parallel to the principal axis. Okay, it is parallel to the principal axis. Now after reflection, you know that this line should pass through what? Principal focus. Where it comes principal focus, it is half of the distance of radius of curvature or not. Then what we can say, between C and P comes F. This we already studied now. That is F here. We should pass through the principal focus after reflection. Now this ray of light, after striking the mirror at M, it is reflected and passing through F, right? This is one. Next you have to consider another ray. Okay, it is passing through what? Center of curvature. There you have to consider another ray passing through the center of curvature. Okay, now you know that this ray after reflection, this ray after reflection, what happens? It is bent. It's not going straight. Okay. Huh. After reflection, it follows the same path or not? It follows the same path after reflection. Right. Now, at this position, where the two reflected rays intersect each other, at this position, we get the image, right? Let us call this image as here A dash, B dash. This is what? AB. We have taken this as AB. This is A dash, B dash. If it is AB, right? Now, what we can take is here. This line, if you want to consider two triangles, you can consider here. What is that here? Triangle A dash, B dash, F you can consider, and one more triangle. We'll shift here F. Just goes to this now. Okay. One more triangle you can consider. M P F you can consider. Okay. This will shift this side. Okay. You can consider, but this is not a straight line. MP is curved line. When it becomes straight line, you have to bring this parallel axis very much close to the principal axis, like this, almost close to each other. Only then this MP, instead of curved line, it reduces to straight line. Okay, right? If you are shifting this line, it is becoming, at this part you consider what this becomes, it becomes straight line. So that is why we are considering the mirrors of small aperture. We say small aperture means what? It is the effective diameter. If this is the mirror, we entire mirror is not considered for reflection. Only little part of the mirror is considered for reflection. Reflection takes place only at this position. So we can say this is effective diameter of that particular spherical mirror. This effective diameter is called aperture. Aperture has to be small. Only this rule of focal length, that is half of radius of curvature equal to focal length or not, that holds good. Otherwise it does not work. So that is why we are considering the what mirrors of small aperture. So what this becomes now here, you can consider triangle A dash B dash F, and now since this line AM, if you take, if it is very much close to this one, paraxial ray we say. Paraxial ray means what? It is close to the principal axis, almost close to the principal axis. Means it should be very much close to this. If you consider like that, then this becomes MP becomes a straight line. Okay. Then you can consider two triangles, that is A dash B dash F. Okay. How we consider? Just you go to this one. I'll not write this one. Just you understand. Very simple. This is right angle. Here also, if this becomes straight line, this will also be right angle. Two angles. These angles are equal, and these are vertically opposed angles. These are also equal. If two angles of two triangles are equal, third angle will also be equal or not. Then both the triangles are similar or not, according to angle property, right? If they are similar triangles, we have to consider their sides. According to basic proportionality theorem, what happens we have to see, right? So we will go ahead with this now. Triangle of triangle A dash B dash F. Okay, triangle A dash B dash F, and one more triangle A dash B dash F. Okay. Next, one more triangle MFP or MPF, whichever we consider. Triangle MPF, whichever you consider, or MFP you consider. FP are similar. They are similar. Why? I have given you the reason, right? Now let us go ahead with this now. Therefore, what we can say here, therefore, according to BPT, B dash A dash upon B dash A dash upon this side MP we can write, or PM, B dash A dash upon PM we can write. PM will be equal to, both are same, PM, and it will be equal to what here? B dash F upon FP we can write. B dash F upon FP we can write, right? Now here PM is what? PM, we don't know the measurement of its length at all. Okay, what to take its length? We cannot take. So what can be considered instead of PM? We can consider this as AB. Why? This line is parallel to the principal axis. If this is parallel, what distance is it? Same distance will be there here also. Then MP will be equal to AB or not? Right? If you consider like that, what this becomes? This PM will be equal to AB. That is how we are getting this. Okay. Why we are taking this AB? AB we know that already. Height of the image, height of the object we know. That is why we are replacing it by what? AB. So if you replace this B dash A dash upon AB or BA, can write this as BA from the principal axis we are taking. So let us make this as BA only, right? No problem. So this becomes what? B dash F upon EFP. You write this as call this as equation 1, right? We consider this over. Now coming to here, one more we want here. What this total length, if you want to consider B dash P, means if you want this B dash P, this is image distance. Okay. If you want this image distance, you need to have one more triangle here. So for that, what we need to do is you consider one more ray of light, okay, coming from this object. Okay, that light ray has to incident on the mirror obliquely, okay, towards pole P. Okay, it has to fall obliquely here, like that you have to consider. So what happens? At what angle it is incident? At the same angle it has to be reflected back, right? If this is angle of incidence, with the same angle it will be reflected, angle of reflection. So after reflection, it is passing through the point F, right? It is passing through the point F after reflection. Now you see, making the same angle with the principal axis according to law of reflection, right? Now here this passes. Now we got here one more triangle here. What is that? A dash B dash P. One more triangle we got, right? This we got. And here similar to that, one more triangle A B P we have got already here. Okay, and if you consider the angles here, APB, angle APB, angle APB will be equal to angle A dash P B dash or not? Okay, angle A dash P B dash. Okay, these are equal, and these are right angle triangles. In that both the right angle triangles, this is right angle, right? Here also right angle. Two right angles are there already, and two more angles are also equal. Then third angle will also be equal, right? So according to angle property, they become similar triangles, right? Okay. If they are similar triangles, what we can say? Therefore, triangle, what is that? A dash B P B dash, and here A dash P B dash you take, and A dash P B. Not A dash, this is A. This is triangle A P B are also similar. Also similar. These are also similar. Therefore, according to BPT, what this becomes now? You have to write this over to again sides in proportion. B dash upon A dash. Okay. B dash upon A dash divided by B dash upon A dash, this triangle BA. That is BA. Now what type of triangles we are considering? In the first case we considered these two triangles like this. Remember, these types of triangles we got in the beginning. Right. Here what was this? A dash, B dash, this was F, this was M, this is P. Like this we got. In the second case, what type of triangles we are considering? Like this we are considering. Right. Here look at this. These two triangles we are considering. Here what is coming here? This is A, B, this is B, this is A dash, B dash, this is P, right? These two triangles we are considering. In those two triangles, these sides we are comparing here. That is B dash upon B dash A dash upon BA we took. This will be equal to what? These two sides you can consider again. What is that? Here B dash P, right? B dash P upon BP you can take. BP you can consider, right? So let us call this as equation 2, right? Equation 2 we got. Now comparing here, this and this, both the factors are equal, right? That is why comparing equation 1 and 2, what do we get here? Both the equations, when you compare, we are getting like this. B dash F upon FP will be equal to B dash P upon BP we are getting, right? Now we can get here B dash F. How do we get? B dash F means what it is? It is the image distance, right? Here B dash F is what? Image is formed here from pole of the mirror. Then it is image distance. So what we can say here, B dash F can be got like this. B dash F means only this much we want, right? B dash P you take total length. B dash P, okay, minus from here to here total length you take. In that you subtract FP. FP means what? Focal length or not? It is, that is that only. FP minus not here, minus FP you can take, right? Substituting this value in this equation, what this becomes now? B dash is instead of this one, or what we are writing, B dash F, we are writing this. So B dash P minus FP divided by FP, we are writing as it is, will be equal to B dash P upon BP, right? We got this. Now let us call this as equation 3. If you want, you can call, no problem. Okay, equation 3 we can call. Now we know that light, when it is incident from the object on the mirror, it is moving from left to the right side, it is in positive direction, right? But after reflection, the light, when it is reflected from the mirror, it is moving in backward direction from right to the left side. So we are measuring the distance of each image object and focal length from the mirror to the left side, right? In the opposite direction we are measuring. That is why they carry negative signs. Okay. Now you know that focal length is what? It is the distance between what? Here. Okay. Focal length is what? The distance between F and P, that is equal to small f, that is focal length of the mirror, right? Next, coming to here, what here, object distance is what? B to P, object distance. Image distance is what? B dash to P, we know this. So what we can do is, let us substitute those values. So what this becomes here, B dash P is equal to, B dash P means what? It is image distance. Image distance is denoted by V with what sign? Negative sign, because in opposite direction. Next, if you take FP, FP is what? FP is what? It is focal length, right? It is focal length of the mirror. So what we can say here, this is negative, so we can write this as minus F, focal length, right? Next, what is remaining? One more, that is BP. BP is what? It is object distance or not? Object distance is denoted by U and it is taken in negative direction. That is why it is minus U. From there to here we are measuring BP, that is object distance, right? Now substituting these values in equation 3. Okay, substituting these values in equation 3, what do we get here. Here, is it visible if I write here? Otherwise, let me continue here. Okay. Okay. Now we'll make this separate part. Should not be mixed up, right? So what we can do is here b dash p means what we have to substitute, minus v, minus v. Next is upon ba, not here, b dash p, that is minus v minus fp, minus of minus fp means what, that is minus f, minus f divided by fp, that is also minus f, is equal to, okay, b dash p, b dash p means what, that is minus p again, divided by minus u, because bp is what, object distance, that is negative, right? How to simplify this now further? Now this, if you simplify, minus v, this becomes plus f, minus into minus plus f, divided by minus f is equal to minus v upon u, let us write as it is, minus u. Now further simplification, use what, remove this minus sign outside, this becomes phi plus f, this becomes now, what opposite signs they get, phi minus f, right? Phi minus f divided by minus f will be equal to, this is minus u divided by minus v, minus v divided by minus u, right? These minus signs they get cancelled, this and this goes, these minus signs they get cancelled. So what remains here? Next, this remains here, phi minus f, phi minus f divided by f is equal to phi by u, phi by u we are getting, right? Now what you have to do, separate these terms. If you separate, what do we get here? Phi by f minus f by f is equal to phi by u you are getting, okay? Now divide this equation, means let us call this as equation 4, no problem. You divide equation 4 by phi, okay? Divide equation 4 by phi. What do we get here? If you divide it, phi divided by, if you divide this, this becomes phi into f, right? Minus this, after cancellation 1 remains here, okay? This gets cancelled, 1 remains, this becomes what, 1 upon phi, right, is equal to this. If you divide, what do we get? Phi divided by phi into u you are getting, right? You are dividing this phi by phi again, right? So what this becomes, phi gets cancelled, here 1 by phi is remaining, minus 1 by phi, this phi gets cancelled. So what we can say, this implies here 1 by f is equal to, no, 1 by f minus 1 by phi, right, as it is, 1 by phi is equal to 1 by u we are getting, right? Now what we have to do is shift this minus 1 by phi to the other side. What do we get here? 1 by f will be equal to, 1 by phi is there, so we can take like this, 1 by phi first, 1 by u, both are same, right? So this is the Miller formula, like this. Now what we are getting here, the relation between object distance, image distance and focal length of the mirror, that is only called what, mirror equation or mirror formula, okay? In this they are related like this. So it is the simplest way. Here I have shown each and every step, how to cancel everything, how to simplify, right? If you follow this, here this is separate part, okay? Don't get confused, okay? This, after finishing I came here, after finishing this I came to this part, okay? Last part it is, means you should not be mixed up. I have shown here complete simplification. So if you go through that without any problem, you will have that complete solution, right? Okay, then next we go for magnification, okay? How to derive the magnification, okay? So you can see here, coming to magnification, how to derive the magnification. See, magnification is nothing but, it is the relative height of the image to the height of the object, right? So what we are considering is, okay, now let us consider two triangles. What, again these two triangles only there. Here what we had taken earlier. Okay, here these two triangles we have to take. Why we have to take these? The reason is, here we want height of the image, height of the object, we want these sides, right? These sides height we want, length. So that is why when we take these triangles a, okay, b, p, and this side a dash, b dash, p. Okay, you have to consider this. So what we can say, magnification is nothing but it is what expressed as h dash by h. H dash by h means how we are expressing this, that is the relative height of the image to the object. That is how we are expressing, right? Then how to relate them here? Height of these over image and object, if you want, you have to consider triangle ABP. Okay, consider triangle ABP and triangle A dash B dash, okay, A dash B dash P, right? You consider these two. So what we can say is, here both angles are equal. There is angle APB, angle A dash P B dash, both are equal, and these two right angles, these are also equal, right? And third angle will also be equal. Then they are similar triangles. So what we can see here, these are uh, these are similar triangles. These are similar triangles. Okay, they are similar triangles. So that is why what we can say. Therefore, you consider these heights, that is b a b dash a dash upon ba is equal to this now, b dash p upon bp, b dash p upon bp. We can express it like this. Now you substitute what is b dash a dash and ba. What is that? This is nothing but b dash a dash means it is height of the image, okay, to the height of the object. You know that. This will be equal to what? B dash p means what? B dash p means what? It is the distance of the image from the pole of the mirror. So distance of the image is minus v or not? That is minus v. And bp is what? Distance of the object from the pole of the mirror. That is minus u, right? Okay, and this height we have to take this as negative. Why? Because it is measured below the principal axis, right? So that should be negative, minus h dash we are getting, right? So now what can we do is, here this and this gets cancelled, right? Both the negative signs. This becomes h dash by h is equal to phi by u. By this is what? Negative sign. It is carrying negative sign. Now what we can do is multiply both sides by negative sign. What do we get here? H dash upon h is equal to minus phi by u we get, right? So this is the relation, and we have already given what is it? H dash by h, it is nothing but a magnification, right? Magnification. So that is why we can say that magnification is equal to h dash by h is equal to minus phi by u, right? So this is what we can say, this as linear magnification. Means what? In a straight line, how they are extending in the heights that we are measuring, right? So that is why this magnification is nothing but it is related by the distance, means object distance and image distance in this way. Okay, after deriving we are getting, and these formula whatever we have derived so far, it may be focal length, it may be mirror formula, it may be, or magnification it may be, these are applicable for all the types of mirrors. Means concave it may be or convex, not plane mirror. These are applicable only for spherical mirrors, it may be convex or concave, and at all the positions of the object wherever it may be, and all the types of reflections. Image may be inverted, erect, real, virtual, no matter. Okay, in all the at all the times it is applicable. You can apply this. Okay, with the proper sign conventions, if you use, you can solve any type of numerical problems. Okay, just in the next class we'll go ahead with how to solve the numerical problems based on these. Okay, it is very much simple. First you need to understand the concepts in depth, only that is required. Okay, okay, then we go ahead with next numericals on this, right?